Have you ever noticed something strange? Sometimes ancient buildings look too modern, too monumental, too geometric, too meticulously designed. We're used to thinking that the future means glass facades, parametric design, algorithms, and artificial intelligence. But what if the architecture of the future has already appeared once before, simply carved in stone? Today we will embark on a journey through 6 ancient structures that look as if they were designed by architects of the 23rd century. And the further we go, the stronger the feeling becomes that humanity may have once come remarkably close to the architecture of the future. Luxor, Egypt. When 19th century archaeologists began systematic excavations in the area of Deir el-Bahari on the western bank of the Nile, their attention was focused primarily on the tombs of the pharaohs. The pyramids seemed to represent the pinnacle of Egyptian architectural thought. However, as the sands were cleared away, another structure gradually began to emerge, less massive, yet astonishingly modern in its spatial logic. The Temple of Hatshepsut does not give the impression of a heavy monument, it gives the impression of a system. Built around the 15th century BCE, the complex consists of 3 successive terraces. Each terrace is connected to the next by straight ramps forming a clear central axis. This is not a random accumulation of halls, but a carefully designed route of movement. A visitor does not simply enter, they pass through an architectural scenario. With each new terrace, the perspective changes. The space expands, then narrows, then opens once again. Modern architects call this the control of perception, when a building does not merely stand, but guides both the gaze and the step. But what is especially striking is the geometry. The colonnades are arranged with near mathematical precision. The intervals between the columns repeat in a strict rhythm. Analysis of proportions reveals a deliberate use of symmetry and balance. This suggests a highly developed understanding of spatial composition. Was this temple merely part of an ancient tradition, or was it one of the earliest peaks of architecture itself? When in 1812, the Swiss explorer Johann Ludwig Burckhardt first reintroduced Petra to European scholarship, he expected to see the ruins of an ancient eastern city. What appeared before him, however, looked more like the set of a film about a distant future. The city was not built, it was carved. Its facades were not assembled from blocks, they were extracted from a single mass of rock. Most striking of all is Al-Hasne. Its proportions are calibrated with exceptional precision. The vertical lines are strogy and commanding, the symmetry nearly absolute, and the decorative elements are integrated into the structure rather than applied onto it. It creates the impression that the stone was shaped by some enormous industrial instrument. Yet Petra's true technological sophistication is hidden not in its outward appearance. Archaeological research has shown that the Nabateans engineered an extraordinarily complex water supply system in the middle of a semi-desert environment. Rainfall here is rare and unpredictable, and yet the city flourished for centuries. Channels were carved into the rock with carefully calculated gradients. Water was directed into reservoirs and settling tanks. Some channels were lined with protective coatings to reduce evaporation. There were filtration systems designed to separate sand and impurities. This suggests a deep understanding of hydrodynamics and the behavior of water within controlled systems. Petra was an autonomous urban mechanism, a city fully adapted to an extreme environment. Today, the concept of sustainable architecture is built on the same principles: local resources, minimization of loss, working with nature rather than against it. And therein lies the paradox. We consider sustainability a technology of the future, yet Petra demonstrates it in stone more than 2,000 years ago. Nan Madol, Pohnpei. In the early 20th century, archaeologists exploring the island of Pohnpei in Micronesia encountered something that was difficult to fit into conventional ideas about ancient societies. Before them stood a city built directly on the water. Nan Madol consists of 92 artificial islets connected by canals. From above, the structure resembles a grid, almost like an engineering blueprint. The walls are constructed from basalt columns weighing up to 50 tons each. The total volume of stone used is estimated at around 750,000 tons. For a region where metal tools and draft animals did not exist, this seems almost unbelievable. Yet even more impressive is the underlying structural logic. The columns are laid in a crisscross pattern, forming a stable bonding system. This method distributes weight and prevents the displacement of blocks. Modern engineers apply similar principles in modular construction. The city is divided into functional zones: residential areas, ritual complexes, and spaces reserved for the elite. This is not a spontaneous settlement. It is a deliberately planned structure. To build a city on water means solving the problem of foundations. Stone platforms were created layer by layer, forming artificial bases. Today, we discuss concepts of floating megacities designed to adapt to rising sea levels. Nan Madol realized a comparable idea more than 1,000 years ago. And once again, the question arises, was this the beginning of architectural thought, or one of its forgotten peaks?
Chand Baori, Rajasthan. When researchers first documented Chand Baori, they described it simply as a stepwell. But upon closer examination, it became clear that what stood before them was not merely an engineering structure, but a geometric system. Around 3,500 steps form a perfectly repeating pattern. 13 levels descend to a depth of more than 20 meters. From above, the structure resembles a three-dimensional algorithm. Each step is part of a unified grid. Each level repeats the previous one with mathematical precision. Yet the form is not created for aesthetics alone. In the intense heat of Rajasthan, water evaporated quickly. The depth of the well allowed it to be preserved longer, while the massive stone walls created natural cooling. The temperature inside could be several degrees lower than at the surface. This is a principle of passive climate control, without fuel, without machinery, without external energy. Modern buildings are designed with consideration for the thermal inertia of materials. Chand Baori demonstrates this long before the term energy efficiency even existed. And when looking at its geometry, it is difficult to escape the feeling that this is not a 9th century structure, but a parametric model realized in stone. And once again, the question arises, was this the beginning of architectural thought, or one of its forgotten peaks?
Mont Saint-Michel, France. When the first sanctuary appeared in the 8th century on a rocky island off the coast of Normandy, no one could have imagined that it would eventually become one of the most unusual urban formations in Europe. Mont Saint-Michel was built vertically. During high tide, the island becomes completely cut off from the mainland, turning into an autonomous fortress. It is a natural defense system integrated directly into geography itself. But the most striking aspect is the organization of space. The lower levels were occupied by storage and trading areas. Above them were residential quarters. At the very top rises the abbey, the spiritual center of the complex. It is a clear hierarchy of functions. Narrow streets transition into stairways, stairways into terraces. Space develops upward, compensating for the limited ground area. Modern megacities are forced to grow vertically due to land scarcity. Mont Saint-Michel demonstrates the same strategy more than 1,000 years ago, and its silhouette, especially during high tide, resembles not a medieval town, but a futuristic vertical complex.
Teotihuacan, Mexico. In the early 20th century, Large-scale excavations of Teotihuacan radically changed perceptions of ancient American cities. What opened before archaeologists was not a chaotic complex of ruins, but a carefully planned metropolis. The main axis, the Avenue of the Dead, stretches for approximately 2.5 kilometers. On both sides stand pyramids and platforms arranged with striking symmetry. The city is oriented according to astronomical directions. The Pyramid of the Sun, one of the largest in the world, was constructed with visual interaction with the surrounding landscape in mind. The scale of the structures was calculated to dominate the perspective, yet preserve compositional balance. At its height, the city's population reached between 100,000 and 150,000 inhabitants. Such mashtaba required an advanced system of supply, administration, and planning. Teotihuacan is not the result of gradual organic expansion. It is a project. And when looking at its strict grid and monumental scale, it feels less like a city of the 2nd century CE and more like a vision of future urbanism.
We have seen 6 structures that blur the boundary between past and future. The future is not always about technology. Sometimes it is scale, symmetry, purpose. Ancient architects did not have computers, but they had something greater: time and ambition. And perhaps the architecture of the future is not an invention, it is a return. Write in the comments which structure impressed you the most, and don't forget to subscribe. There are many more stories ahead where the past looks like the future.